So it's 3 minutes past 8. Let's begin. So this is the Gren Summer 2024 release, or it's happening on Monday, but it's available now. Um, and I thought it would be nice to go through a couple of the nice new features, do a short demo, and then talk about where we're headed in the next 6 months. Um, so um, yeah, that's what I just said. So what's new in the summer 2024 release? First off, I'm just gonna stop using version numbers to refer to new Gren releases, mostly because they don't make a ton of sense. I will refer to Gren 04 in the release notes, but that's just the compiler version. The core packages have different versions, so I think just referring to the time of releases is less ambiguous going forward. But what is new in the summer 24 release? That is a brand new file system API that should allow you to do a lot more stuff when writing Node applications. We've had some improvements to the existing APIs, especially for data structures. Work has also begun on Gren in Gren, which I'm pretty excited about. Justin has made improvements to the book, hopefully making it easier to get started with Gren. And we moved to Discord away from Sulip. We asked people if one of the reasons that they weren't on the Sulip was because we were using Sulip, and a surprising number of people said yes. So we've moved to Discord, and um, in the short week or two we've been there, we've already seen more activity than we've ever had on Sulip. So it seems to be the right choice, if a pragmatic one. But moving on, so we have essentially rewritten the file system API. The file system API that we had for Gren previously worked, but it was pretty basic. The new file system API covers pretty much most of the built-in API that's available through Node. I had this other video where I talked a lot more about it. And you will see a little bit of it in the demo afterwards. But essentially, you can do, I don't know, 90% of the stuff that you can do using nothing but Node, you can do in Gren now. There are certain platform-specific APIs that are not available, and we haven't yet figured out streams in Gren, so file streaming, reads and writes don't work quite yet. But other than that, you can do most of the things that you would use a file system API for from Gren. We've also added support for, we've also added like a type safe representation of paths in file systems, which also should be a little bit easier to work with. Which is cross-platform as well. So if you want to know more about the file system APIs specifically, there's a separate video that you can watch. I'm not gonna dwell too much more into it here. There's also been some improvements to the existing API, and mostly centered around data structures. So for arrays, you now have indexed fold and indexed fold R functions. We've started to use more kernel code under the hood in order to improve performance. One of the interesting side effects of that is that you can now use negative indexes when retrieving or setting a value in the array. And that's because we use the .at and I believe it's called with functions in native JavaScript, and those support negative indexes. So essentially, if you want to get the last element of an array, you can now use -1 as an index. So that's arrays. When it comes to dictionaries and sets, we have removed the from array and to array functions. For dictionaries, well, they're still there for sets, but for dictionaries, they don't make a ton of sense. So instead, you just just build up an array from the empty array using a pipeline, or use array fold or set fold or whatever to build up your array gradually using dict set. It should be faster, but it also, what we found out was that using from array didn't actually save you any lines of code, so it was slower and didn't save you anything really. So we just removed that so people would use dict.set directly. We've also added several functions to dictionaries and sets uh, to cover the API gap with array. So we've added a find function and any function filter map. There are a couple of others as well. And the reason for that is to reduce the number of times you will have to convert from dictionary to array just to call a missing function. So that should be helpful. It should allow you to stay within a set or a dict for longer, or use them where they make sense and not based on the functions available. We've also added a few changes to the bytes data structure. So bytes, as the name implies, is a container of bytes. We've added a from string and a to string function to simplifies the case, which is a very common case when writing Node applications, to convert between bytes and strings. And in order to make that as fast as possible, we now use the text encoder or text decoder JavaScript class for that. So it should be a relatively fast operation. It should be faster than using the byte encoder, the decoder API. We've also added a join function for taking array of bytes and flattening that out to a single bytes data structure. And what isn't listed here is that there's also a function for creating the empty byte structure and returning the byte length of a byte structure. And these are things that just makes it a little bit easier to work with bytes, which you do a lot more when writing Node applications compared to when writing browser applications. We've also done some things around tasks. So there's now a task execute function for turning a task into a command without requiring you to specify which message you want to send to. Oh, essentially, it just doesn't send the message when it's done. And that's useful for certain tasks where you want to perform the side effect, but you don't really care about being notified of what happened afterwards. We added a task await function. This function is essentially the same as task and then. It just has the arguments reversed, and it makes it a little bit easier to do to write imperative side effectful code in the same way you chain initialization tasks in Node. You can now do that with regular tasks. And the stream send functions, stream send, send line, send string, they now return a task instead of a command. And that makes it easier to first do one task, then do another task, and then write to the standard out and quit the application. You can do that in a single pipeline now, where before you'd had to go through the Elm architecture to do the same thing. And if you want to call stream.send and that's all you want, you can use task execute to turn that into a command quickly. We did the same thing with the node.exit functions for the same reason. Another big change with the summer 24 release is that parts of the compiler is now written in Gren itself. That sounds like a much bigger change than it actually is. We've essentially replaced the JavaScript installer for Gren that you used if you were installing Gren from npm. So that part of the compiler is now written in Gren instead of JavaScript, which isn't much, but it's a start. And from here, it becomes very natural to kind of like gradually extend that wrapper application to take over more of the Haskell-based compiler. And we will gradually, incrementally take over from here. And there are several reasons why we went this route. One of the most noticeable things is that this will direct the APIs that we will write. So in the past 6 months, we've added an HTTP client API and we've rewritten the file system. And the main reason for doing that was to enable this tiny sliver of Gren and Gren. And moving forward, we will probably either improve or add APIs to further enable to essentially enable us to rewrite the compiler gradually into Gren. We will add stuff to make that happen. And as the compiler gets more mature, we will start to convert other projects in the Gren portfolio, I would say, like the package site and the grenlang.org. We'll start to rewrite that into Gren as well, and that will also reveal missing APIs, missing functionality that we can add. Another good point is that since we're now actually dogfooding our own APIs, chances are that we will uncover bugs that are hard to find in other ways, especially considering the currently low amount of people who write Gren. And we've already found several bugs in this way, which is why if you install Gren from npm, you will find that the version number isn't actually 040, it's 042, because in the deployment phase error, I discovered 2 critical bugs that I had to fix right away. And another interesting point is that I now get to suffer the consequences of my design choices. And I think this is a good thing for any language designer to actually get to feel the pain you inflict on everyone who chooses your language. It gets me to actually battle test my design, which is ultimately a good thing, I think. There are other things as well. I'll probably get back to Gren and Gren in a more in-depth video sometime during the fall, but I think these are the main points. This is something that I haven't done, and this is something that's been out for a little bit, but it's something that gradually improves. Justin Blake has taken upon himself to improve the Gren programming language book, which is our main teaching material essentially. The first thing he did was to rewrite the entire thing in Astro and Starlight, which gave us a nice UI upgrade, but it also added search to the book, and the tool that actually generates the book is now version controlled, which wasn't the case previously. And if that wasn't enough, Justin has also added a few missing chapters and added some brand new chapters on his own. And the book, as well as the packages site, now supports mermaid charts, which allows for some, which should enable easier to understand documentation through visual charts. So that's great, and I assume it will continue to improve from here on out. So those are actually the main changes. There are a few changes to the compiler as well, but nothing major. Improvements to some error messages, a little bit stricter syntax around multi-strings. Yeah, that's pretty much it. But there isn't a lot in the way of language changes or compiler changes. It's mostly an API update. So with that out of the way, let's do a short demo where we get to touch upon some of these changes. We begin with initializing a new project. This yes flag is one of the changes that are new that I haven't really bothered mentioning, but it's helpful for scripts, I presume. So we now have a brand new Gren JSON project. I wonder if it's easy to see this. I'm gonna try to improve the font size, which I never remember how to do. There you go. There, that seems a lot more readable, if comically big on my screen, but it seems to be a nice aspect ratio on the screen. So we're going to initialize a very simple node application. I'm going to start by creating a Gren file. Execute that, should say hello world, which it does. It's sort of, this example isn't very impressive, but it's actually inception levels of things going on there, because we just executed a tiny Gren program, which executed a Haskell program that compiled a Gren program that we now run. I might be the only one who finds that a lot funny. Let's move on. So we're gonna start by building a node application. So we're gonna go in and we're gonna see how we can write a simple program. A simple program is essentially a program without the Elm architecture. It allows us to start up a program and run a pipeline of tasks. And what we're going to build is a program that reads a specific file, sorts the line in the file, and writes it back out. Which should, it's something that should be able to be a pure task-based operation. So we're gonna have to use this function, define simple program. So input node, this is the node namespace, yes. Main then defines a simple program. I'm just gonna I'm gonna add there some syntax highlighting to make it simpler. This is Elm syntax highlighting for those who are new. Elm and Gren are still pretty similar, so that Elm syntax highlighting still works decently well. So the init function is going to take an environment object which contains some basic information about your program and the environment that you run in. You can find that in documentation here. So if we right, so in theory we could so we're going to write hello to standard out. We are going to execute that task, which returns a command. Then we're going to use end with command, or probably this. And that is our simple application. I'm just going to compile this to see if I got this right. I did not. Because of tabs. Can't find that function, which is because I haven't imported this. And this. Interesting. This should be wait, what? This is, by the way, an initialization task. It's a task that can only run when an application starts up. You will normally only do it at the very beginning of your program. But now it's compiled, it writes hello. So that means we have a simple program. And we kind of like have a branching point now for adding more tasks. Right. So what we're gonna need now is a file called unsorted. And I'm going to add all the names that I see in the commentary section. So I can do this because there weren't that many of you. So here we go. That's unsorted, and almost made a mistake there. So we're going to write a program that reads unsorted, sorts it, and writes it into a sorted file. And that's it. That's what it's going to do. So the first thing we need to do is to read that file. So we go to the file system API, and you can see, I'm just going to scroll, and you will see that there is a lot more in this than there were before. More specifically, there should be a read file, which takes a file system permission and a path. Now, so we're going to have to import the file system. We are going to initialize the file system to get the permission to perform file system operations. I think that's correct. I'm just going to double check here. This still compiles. Let's see. Tabs. I should probably fix that, but not today. So this still works. So now we have obtained the permission to perform file system operations. And to some, it might seem a bit silly that we're asking for permission to perform file system operations, but it's something that helps you when third-party libraries involved. You can be absolutely certain that a third-party library won't be able to perform a file system operation if you didn't give it the permission to do so. So we're going to call this the read file. The read file function, and that is going to take a permission value, and it's going to require a path, I believe. Yes, a path. So we're going to have to construct a path, and we have this from POSIX string that allows us to do that. So we're going to need to import another module. Do that like so. I think I can just do that. So that gives us a path. That should read said file. As task, and so we're going to turn that as long as that goes okay. There we go. If that goes well, we're going to get a series of bytes. Those bytes we're going to turn into strings. And so we can call our new, we can use our new helper function for that. Bytes to string. And now that the contents of that file should now be converted into strings. And then we should be able to split that into lines, and then we should be able to sort that. Finally, we should be able to join that sorted array back into a string value again. We can then change it back into bytes. Actually, before doing this, let's just check that we have in fact sorted it. And then, because we can't compile a program unless we handle the error in some way, we are going to change the error, or we're going to turn the error into some error string and just write that. To the terminal. I think that should work. Oh, right. Should probably pass in the string that I wish to split. Right, so turning bytes to string doesn't necessarily work. Do that. So that worked, or it compiled. And yeah, it did in fact read the unsorted file and sort it. And I guess I just happened to write it in reverse order. I'll do that just for kicks. Yep. So that does read from the file, sort it. And spit it back out. So now we have to turn that. This should probably work, right? So now we have bytes. We're going to have to write it to the disk, which is this write file. Takes permission, bytes, and a path. That's a permission. And the path. So it's written to file. Finally, um, but if we had an error, we're going to report. So we're going to say after we've written the file, we're going to say we're done. If there was an error, we're simply going to write the error string instead, which will be written to send it out, and then this will be executed and ended. So let's see if that works. And I have a typo right there. It said done. And we have a sorted file. That sorted file contains those names in sorted order. So that was it. Here you have an example of using a few improvements to the bytes to string API, and then we can actually read and write quite easily. This is, and if you're doing like simple scripts, you can actually do this in relatively few amount of lines, which is nice to see. So that concludes the demo. So now we have done, some nice API improvements. It's time to look ahead. So the new compiler, the new APIs, all that is it's actually available now if people want to mess with it. But the official announcement goes out on Monday, and after that, it's time to focus on the Christmas release. So for the Christmas 24 release, I hope to continue the Gren in Gren work. I hope to write the command line interface of the compiler in Gren and hopefully remove something from the Haskell compiler um, in that process. And every line of Haskell code we remove, we improve the total compilation time of the project because the Haskell compiler is actually quite hard. Yeah, or it's not hard. It takes a while to compile, and so gradually rewriting that again is likely to net us an improvement in compiler performance overall. Um, in addition to rewriting more stuff in Gren, I also hope to make a change to the compiler that improves function call performance. So there's a project out there called Elm Optimized Level 2, which has performed its most important optimization is to improve function call performance of Elm code. And I essentially want to take some of that and move it into the Gren compiler proper. And I think that's especially important as we're starting to write the compiler, the Gren compiler in Gren itself. I also hope to make the HTML and SVG API cross-platform, by which I mean that you should be able to define an HTML view or an SVG view, and you should be able to use that server side and browser side. This is already possible today through the transmutable HTML API that Steven has written, but I want to make that a part of the official API, and I want to see if we can make that more performant than what is the case today. I also want to take a look at the URL package and remove custom operators from that, and move that into the core package. The URL package is a dependency of the browser package um, and the node package today. So it really is like a common dependency. And I think it's time to actually give it a good review and merge it into the core package itself. Also, custom operators. The URL package is one of the few packages that has its own specific operators, and moving forward, Gren is not gonna it's not gonna support that. Gren's gonna support a very small amount of operators. Um, and so custom operators from the URL package, as well as the parser package, will be taken away, although the parser package won't be reviewed until we get to the stage where we rewrite the parser package in Gren itself. So it's a little bit into the future, but it will happen. But I hope to at least get the URL package merged with core before Christmas. And then any functionality, any API, anything that has to improve in order to support the above goals, perhaps specifically um, rewriting the command line interface of the compiler in Gren itself, will be added as well. So if there has to be improvements to the child process API, then I will look into that. Anything to continue rewriting the compiler into Gren. Now, it's important to mention that these are my specific plans. There are other people working on Gren related issues now. I know someone is working on a new core API that I hope to release in August or September. And there are other things happening as well. So this is just what I plan to do, but it would surprise me if this is the only thing that happens between now and Christmas. Uh, Speaking of, if you want to help out, if you want to help the Gren project, if this seems like something you want to do, or this seems like something you want to exist, I suggest that you use it. Write simple stuff in it, report any bugs you find, let me know of said bugs, or contribute with a pull request. That's always appreciated. Or you can write about Gren, talk about Gren, try to get other people into the community. If you're feeling very bold, you can create packages to improve what we can do in the language. Or, if you're feeling very adventurous, you can reach out to implement a missing API or language feature that you want to see exist. If you do want to go that route, though, I would suggest you ask on the Discord first. Um, um, I tend to want to talk things through before implementing stuff. And finally, consider sponsoring me on GitHub. Um, the development of Gren isn't very cache sensitive right now, but it is a way of showing that you really support the project, and it's highly motivational. And all the money I get from sponsorships, it goes into a dedicated account. I think we have around $500 now, and at some point, it would be something that we can actually spend on something worthwhile. So uh, it doesn't go to waste. And that's really all I had planned to say, planned to show off. I'm gonna hang around for a couple of minutes, take a um, take a hard look at the comment section, see if there are any questions that um, would be worth or not worth. Uh, See if there are any questions that pops up, and I'll answer them to the best of my ability. Right, so there's a question, someone's asking that they think they saw a virtual file system package. I don't know of one, but the follow-up question is, does that mean flushing the virtual file system to disk is bound by the permission system? And it is, yeah. Anything that has to do with the file system requires a file system permission in order to execute. And I might also mention that the entire permission system is something that it's something that we're testing out in a way. I think it's a good idea, at least on paper. But one of the benefits of Gren is that I get subjected to the pain of passing permissions values around. So if the permission system ends up being very painful, then it might be removed. But I don't mind it terribly right now. So there's a question, are there any VASM related news? There are not. It's something that I think about a lot. Um, so um, VASM is far down the line, but every language feature that I think about or try to implement, I do keep VASM in mind. Like, would this make VASM harder or easier? Um, so I don't have any specific news, but it's definitely something that's on my mind a lot. Um, the permission system sounds like a good idea, but maybe it could be opt-in if people trip over it. I think the permission system, like I think that's certainly a suggestion, but I think the permission system is something that makes a lot of value if it's like if you could easily circumvent it, then I think it doesn't have as much value um, as if it's a requirement. You can kind of like compare that to mutability. If you allow mutability in one place, you're going to lose that pure aspect of language where you are guaranteed that there are no mutations, no hidden mutations ever. And the permission system is sort of like that as well. If you can easily opt out, then I think it weakens the value proposition of it. Yeah, so they're saying similar to Dino with regards to our permission system. I haven't personally used Dino, but my impression of that is that you pass the permissions before executing the application. I think you when you start a Dino application, you have to add a command line flag that says that you're allowed to do file system operations in this folder, for instance. Whereas we have it in the actual source code. Um, so we don't limit the application itself, but we limit the source code within that application, if that makes sense. So the application author has full control over what parts of his or her application can perform file system operations, but the application itself isn't sandboxed. And I think in Dino, the application itself is sandboxed, but the source code itself, there's a free for all. I might be mixing Dino up with something else, but that's my impression. All right, I think I'm gonna call it there. Thank you everyone for tuning in and watching the live stream. This will be recorded, so you can share with other people later on, refer to it as well. I will be hanging around in the Discord for the next hour or two to as I rewrite example projects and make sure that um, every package works as is expected. All right, thank you for watching.